Hello learners, this is Priyadarshi Shubhakant and once again I welcome all of you to my sessions on CNC milling machines, and today we'll be discussing once again regarding the G codes. Previous classes we have discussed up to G42, and after that what are the different G codes that are used in CNC programming we'll be discussing in today's session. So without wasting much of the time, let us start today's session. So first of all, before starting the G codes, I'll just share a few things with you, that is regarding machine coordinate system, work coordinate system and relative value. So these are the three different values which are present in the CNC machine position screen. So here what happens now, what are these three different things? First of all, MCS is what? Machine coordinate system. This coordinate system is set by the manufacturer of the machine and these coordinates cannot be changed. And here next is what? Work coordinate system. Work coordinate system means the job we will place it on the bed of the machine or in the vise, and in which we are going to do the operation. That job or the workpiece reference point, when we are going to set it, that particular is known as work coordinate system, and sometimes it is also known as the absolute value in FANUC controllers. And another method or another value is there, that is the relative value. This is the reference that can be set by the operator at any time, but it will not hamper the MCS as well as the WCS. That means this for the operator's requirement or the need of the operator, accordingly he or she can set these coordinate points, and it will not hamper, once again I am repeating, it will not hamper the WCS or the absolute value. So these three things we should know that one. And after this, let us start the G codes. The first of all, next important G codes after G42 are, I can say that one, that is G54, G55, 56, 57, 58, 59 up to this, and these are your work coordinate system. So in work coordinate system, generally what happens now, in this if you are going, you are activating particular work coordinate system. 1, 2, 3, 4, 5, 6, these are the different work coordinate system are there. That means particularly here what happens, if for a particular job you have set its origin point in G54, that means if you are doing the programming, you have to write G54 to activate particular work coordinate system. If another second job is there and in that you have set it reference point or the origin point, I can say that one, in G55, that means if you are going to do the programming for a particular job, you have to write G55. So accordingly the machine will understand that which job reference point I will consider. That means the machine will consider. So here what happens now, in different work coordinate system you can set the value of a particular job that you have loaded on the machine. So in upcoming classes I'll be showing you how to do the work offset system, means how to offset a work. In that we'll be having the sessions, but for at the moment you know that in this there are different types of work coordinate system where we can store the origin or the datum point or the starting point of a particular job accordingly. So here G54, G55, 56, 57, 58 and 59 are the different work coordinate storage system in which we can store the origin of a particular job, and as per that we have to do the programming. Then moving on to the next codes, let us start that one. Next we can go, that is G80, and G80 is what? Now it is a canned cycle cancel. So canned cycle cancel, generally what happens, let me tell you before that what is canned cycle. So canned cycle, what happens, we need not to write repeatedly each and every coordinate for the movement of the tool. Simply for example drilling or boring or rimming or similarly type of operations, if you want to repeat it, then we can go for canned cycle. That means we'll give the starting parameters, ending parameters, along with that other parameters whatever it is required, we will be giving it and the machine will be doing those operations. This comes under the category of canned cycle, and to cancel the canned cycle generally we use G80. And you can see the command whatever I have written over here, that is G83 X20 Y15 X-12 R2 Q400 and F50. So this is a complete canned cycle for drilling a particular hole. with a depth of 12 mm at a particular given coordinates. So let us know what are the different parameters I have given in this drilling cycle. So here you can see like X and Y are the hole position data, and then Z is the depth of hole starting from the reference plane, R is the position of reference plane, that means from 0 which plane is the reference plane, then Q is the incremental depth of cut in micron, that is 5, I have given 400 micron over here. The next F is your cutting feed rate, that means at what feed it will cut it, that means at a feed rate of 50 it will be cutting the material, that means 50 millimeter per minute, that is the feed rate. So this was regarding one of the CAN cycle. Other CAN cycle I'll just tell you the codes regarding that one, and G80, remember to cancel this CAN cycle G80 code is used. Then moving on to the next one, you can see over here G84 is for tapping cycle. For example, you want to do a tapping that generally performs a internal thread. For that you can use G84. The detailed parameters we'll be discussing in our upcoming sessions. G85 is boring cycle, and here without dual. And what is dual? I had told you in your previous session.
G86,
that is also boring cycle, and it is spindle stop rapid out, that means it will do the boring and the spindle will stop and it will come out, rapid out, quickly it will come out. Then G87, it is back boring cycle, that means it will do the boring from the bottom towards the top. The next G88, that is boring cycle, spindle stop, manual out, that means it will do the boring and the spindle will stop, and manually we have to remove the tool out from the boring hole. Then G89, it is also boring cycle, but this time it is with the dual, that means the dual time will be there, like G04 code you can use in that one, so that you can remove the chips properly. Then next we can go for one of the important thing, that is the G90, that is absolute mode. So in this G90 what happens, now to do the programming we need to know the coordinates, that means when we are going to run a program, before that we have to write a program, and to write the program as per the drawing dimensions we should need to find out the coordinates. And here what happens, coordinates are of two types, one is absolute, another one is incremental. So in this particular slide I am going to explain you regarding the absolute coordinate system and incremental coordinate system. Here you can see we are having a rectangular block with a dimension of 80 millimeter length and 60 millimeter width, as on the slide it is showing you. You can see that one, and the cutter, that orange color blinking mark is there, that is the reference point of the cutter, that the value of that one is how much, na x0 y0. And if the cutter move towards the left hand side, then what next coordinate it will move on? The next coordinate will be in x-axis, it will be -80, and in y-axis it will be 0. Then again if it will move towards the upward direction, then the coordinate we are getting over here, that is x -80 and y is 60. Then next when it is moving towards the right hand side again, and in that what coordinate we will get it, that is x0 and y 60. And if again it will come to its origin position, it will be same as x0 and y0. So here what happens, now the origin position is fixed, and as per that we can give the coordinate values to which the cutter will follow, and it will move as accordingly it is showing in the slide. Then moving towards next, that is your incremental mode, keeping the absolute mode aside. Same way in incremental mode what happens, now we can see same length is there, that is 80 millimeter length, 60 millimeter width, and here the cutter reference I have taken in the opposite direction the cutter will move. So here I have taken the starting reference point as x0 and y0. When the cutter will move towards your right hand side, the first coordinate you are getting, that is x80 and y0. Then when the cutter will move towards up, it will be x0. Here x we cannot keep it 80, because if we will keep 80, again it will move 80 mm towards the right hand side. So here we have to make it x0, and y we have to give 60. Then next when we have to move to the left hand side corner, then again which coordinate we have to give? We have to give x -80 and y0 we have to give. Y we cannot keep 60, we have to give y0. And then next again if you want to come to the origin, we cannot use x0 y0. If you are using x0 y0, it will be there in the same position where it is now at the moment. So come back to the origin, again we have to use x0 and y -60. So that is the difference between the absolute mode and incremental mode. So I can say that one, in absolute mode the origin is fixed, whereas in incremental mode the previous point of the cutting tool is considered to be the origin. So these are the difference between absolute mode and incremental mode. So which mode you are going to use, you can select it by using the code G90 and G91. So next we'll be moving towards the G codes, that is G94 and G95. So these two G codes stand for the feed rate. So here what happens, the feed rate is in mm per minute, another one is mm per revolution. So G94 mostly used for milling machines and G95 usually used on the lathe machines, CNC lathe machines. So G94 is what? It is the feed rate, that is in the millimeter per minute, and whereas G95 is what? Now millimeter per revolution, means if the cutter rotates 1 revolution, how much millimeter it will advance, and in 1 minute how much the cutter will advance in a straight line or in a particular profile, that is regarding the feed rate in mm per minute, that is G94. So that was all regarding the important G codes that we are using in our CNC milling machine programs, basic program I can say. That was all regarding the G codes. So thank you for being with these sessions, and in the coming session we'll be discussing regarding the different types of important M codes which are used in the programming. So stay tuned to our CNC milling classes. For today this much. Have a good day. Thank you.